So let's see if you listed everything that you noticed about these polynomials. What does each polynomial have in common? Well, hopefully the first thing that jumped out was each of these polynomials only has two terms. And if you remember, what is that called when we only have two terms? Well, they are all binomials. Hopefully the other thing that you noticed is all of them have subtraction between them. Not sure if you saw this or not, but they're all four of these are quadratics, and that's going to be true most of the time. But in all four of these quadratics, notice how they don't have the linear term. They're missing the bx, or missing the linear term. But the last thing, the biggest thing that you should have noticed was all of these terms, every single term that you have here, they are all perfect squares. So what is a perfect square? Well, it is a number times itself. So in math, we have a lot of perfect squares. And perfect squares should be something that you should notice, that should stand out. So the first perfect square that you have is 1. Why is 1 a perfect square? Well, because 1 times 1 is 1. The next perfect square that you have is 4. 4 is a perfect square because 2 times 2 gives you 4. Next would be 9 because 3 times 3 is 9. And so you can go on down the list. 16, 25, after 25 would be 36. Then 49, 64, 81, next would be 100. Oops, can't see that. Then after that would be 121, 144, and 169. I could keep on going, but you get the point. So you should know your perfect squares from 1 all the way up to 100. For sure. Really and truly, you should know them from 1 all the way up to 144. But these are called perfect squares because it's a number times itself. So how do you undo a perfect square? Well, to undo a perfect square, you have to square root it. So what is the square root of 169? Well, the square root of 169 is 13. Why is that? because 13 times 13 is 169, and I'm looking for perfect groups of 2. So the square root of 169 is 13. Well, what is the square root of x squared? The square root of x squared, well, x squared breaks down into x times x. Again, you're looking for that perfect group of 2 to come out of the radical. So the square root of x squared is x. So in all of these terms that you saw, hopefully the big thing that stood out was you were dealing with perfect squares.